Hi and welcome to another video on the chapter simultaneous equation. So now you are going to focus on solving simultaneously equations still in two unknowns, but this time you are going to deal with one linear and one non-linear equation. So here, if you have a look at the steps of success for this particular subtopic, you are going to focus on using substitution method only, because this is one of the most effective one for solving simultaneous equation with one linear and one non-linear. So the steps are over here. Let's have a look. Change the subject of a chosen equation, and then what you do next is substitute the expression into the second equation. And then once you have substituted the expression into the second equation, you will notice that you will always get a quadratic equation. So you are going to solve it to get the solution of the first variable. And once you have the solution for the first variable, you are going to find the solution of the second variable by also doing substitution on any equation that you would like to find the value. Alright, so let's have a look at the concept first. So substitution method is the most effective method when you are dealing with one linear and one non-linear equation. So here, let's have a look at this diagram that you can see here. So here, if you try to find or to get the graph for both equation, so here number 1, y equals to x plus 1, so this is the graph for that equation. And for the second one, for the second equation, this is a non-linear equation. You can see here you have an x squared minus 5. So for this particular part, this is the equation number 2, which is y equals to x squared minus 5. Now if you have a look carefully, these two graphs will intersect, or they will meet at two different points. So these two different points are the solutions for the simultaneous equation. So here you can see at A is x equals to 3, y equals to 4, if you read the coordinates carefully. And as for the second one, B, the answer for x is -2 and the answer for y is -1. So that's the concept of simultaneous equation. Simultaneous equation, if you deal with the diagram, you are solving it simultaneously. And with the solution means that you have found the coordinates of the points of intersection of two graphs. So in this case, the solution is given there. So let's have a look if we try to solve this algebraically. Algebraically, when you use substitution method, so here, equation number 1 is linear and has a subject of y, right? So this is x plus 1, and equation number 2 is the quadratic part. So here, what you can do is, when you use substitution method, you can actually use any two, you can substitute one of them into another. So for example here, let's substitute equation number 2 into equation number 1. So let's have a look here. What happens next is that x squared minus 5 will be substituted into equation number 1. So what you have on the left hand side is going to be x squared minus 5 equals to equation number 1, which is x plus 1. So this is one of the simplest substitution there. So when you proceed with the working, let's move whatever variables are there on the right hand side to the left hand side. So here x squared minus 5 minus x minus 1 will give you x squared minus x, and then minus 5 minus 1 is going to be minus 6 equals to 0. So you notice here, this is a quadratic equation. Okay, this is a quadratic equation. There's an equal 0, but on the left hand side is a quadratic expression. So here, what you can do to find the values of x is a concept in mathematics D or IGCSE maths. This is you are trying to solve this quadratic equation by factorization. So if you still remember the very first lesson on basic algebraic technique, you can actually use cross method to find the factorization on the left hand side. So here, this is what we usually do, and I will just straight away give you the solution. So here, to get the negative x in the end part, you will use negative 3 and plus 2 for the factors of negative 6. And when you cross multiply this, negative 3x plus 2x is correctly, you will get negative x correctly. So for this part, you will write down next x minus 3 bracket x plus 2, which you have done before. Now here, since you have a double bracket equal to 0, so basically here, if you learn some part of Maths D, this is actually trying to say that x minus 3 equals to 0 or x plus 2 equals to 0. So now I'm just going to briefly explain the concept of getting this. So imagine that these two expressions are called A's and B's. So here, you are trying to say that A times B equals to 0. So logically, only one of them is 0 because 0 times 0 is not equal to 0. Yeah, this is a concept for maths. 0 times 0 is not 0. But then here, either A is 0 or B is 0. So that's what I'm trying to do here. So which means you have two different values. So because say if A is 0, then B is not 0. Or if B is 0, then A is not a 0. So that's briefly the concept of getting two solutions here. So here, therefore, the first x is equals to 3, or you can put comma x equals to negative 2. So this is your solution for the values of x. And now, for both values of x, you must also get the values of y for each. So here, you will find the values of y for each x. So here, what I'm doing here is to write down two solutions at the same time. So what you're going to do is, for each value, you might use one of the equation above. So for example, here, I'm going to use equation number 1. It's easier. Y equals to x plus 1. So here, let's move forward. Y equals to x plus 1. Okay, just write both of them down. And then substitute x equals to 3. And here, substitute x equals negative 2. So here, y equals to 3 plus 1. So the first solution for the x equals to 3 is y equals to 4. And as for the second one, for x equals to negative 2, y equals to negative 2 plus 1, which will give you y equals to negative 1. So here, both values, if you check it back with the diagram, one of the value is negative 2, negative 1. So this is A. And then for the second one is A equals to 3, 4. 3, 4 is x equals to 3 and y equals to 4. Therefore, this is correct. And this method is widely used if you encounter simultaneous equation when you have one linear equation and one non-linear equation. Now, moving on to the next page. So here, you have two equations also. So y equals to x squared plus 3x plus 2. So let's call this the first equation. And the second equation is 2x equals to y minus 8. Again here, since you have a subject of y in the first equation, so that's going to be substituted into the second equation. So here, you can state it like this. Substitute equation number 1 into equation number 2. So here, number 2 equation is 2x equals to y, which will be replaced with x squared plus 3x plus 2 minus 8. So let's have a look. 2x equals to x squared plus 3x plus 2 from the first equation, and minus 8, don't forget you have it there. So here, if we try to simplify this into a quadratic equation, okay, quadratic equation, I forgot to tell, make sure that you have something like this format, quadratic expression on the left, and it must be equal to 0 before you try to attempt factorization. So here, going back here, maybe we can move the 2x to the right hand side to get equal 0, and then on the right hand side it's going to be x squared plus 3x minus 2x simplified will be positive x, and then plus 2 minus 8 is going to be negative 6. So here, let's turn this around, and now you have x squared plus x minus 6 equals to 0. And now I would like you to attempt this by yourself and pause the video to find the solution, to continue this working and to find the final solution. Alright, now this is the full working to find the solution for this example. So please have a look carefully on all the solution. Now moving in a bit to briefly explain. So if we proceed to factorize x squared plus x minus 6 equals to 0, then you will have x equals to negative 3 and x equals to positive 2. And if you try to find the solution for each x, for x equals to negative 3, you substitute the x equals to negative 3 and x equals to negative 2 into the second equation, which is a linear. It's quite easy. So 2x equals to y minus 8, and x is replaced with negative 3 and negative 2. So for the first solution, for x equals to negative 3, you will have y equals to 2, and for x equals to 2, y equals to 12. Alright, moving on to the example number 3. So this is taken from a passive paper question. So here you have two equations, x plus 3y equals to 13 for the first equation. And then for the second equation, x squared plus 3y squared equals to 43. So this is your second equation. So here the tips that is given for this particular question when you don't have a subject. Of course, you can change any unknown to become a subject for any equation, but preferably please change the subject for only linear equation, which makes it easier. Okay, so in this case, we can make x the subject for the first equation, and what you can do afterwards is substitute the expression on the right hand side to the second equation. So here if we try to make state this, you can just write down the sentence, or this is optional. Make x the subject of equation number 1, or just write down 1. So which means you isolate x and move 3y to the right hand side. So you will have x equals to 13 minus 3y, and let's call it equation number 3. So what happens afterward is that you have to substitute equation number 3 into equation number 2. So what happens here? Let's check number 2. X squared plus 3y squared equals to 43, but the one unknown that will be replaced is x. So here 13 minus 3y power 2, but here it is affecting the whole 13 minus 3y. Please give it a bracket, and then the whole expression is 13 minus 3y squared plus 3y squared equals to 43. This is the second equation. Now for this part, square, which this means this expression has a double bracket, 13 minus 3y bracket 13 minus 3y, and the rest of the expression is still there, 3y squared plus 43 in this equation. So here I believe that at this point you have learned how to expand double bracket expression. So here this means you somehow are familiar. So if you're not familiar yet, this is how you do expansion for double bracket expression. So 13 must be multiplied, 13 in the first bracket must be multiplied with the expression on the second bracket for both. So here 13 times 13 is going to be 169, and then 13 times 3y is going to be negative 39y. You are going to do the same thing for the second term in the first bracket, which is negative 3y. So here you must expand negative 3y times 13, which will give you negative 39y, and negative 3y times 3y is going to be plus 3 times 3, 9, y times y is y squared. But do not forget the whole equation, okay, because you still have them, and this equation must be simplified. So here let's write down the y square first. Okay, what are the like terms? So here it's going to be 9y squared plus 3y squared is 12y squared, and the next term is y. So here negative 39y minus 39y is minus 78y, and plus 169 equals to 43. So this 43 must be moved to the left hand side to make it a part of the equation. 12y squared minus 78y plus 126 equals to 0. Now for this equation, here you might have noticed that you can actually simplify this whole equation. And how do you simplify this? Is by noticing that you have a factor, you have multiples of 12 over here. So for 12y and negative 78y plus 126, you can actually divide the whole equation by 12. Okay, this only works for equation. Okay, so here, this is not 12. Okay, excuse me. The factor, the 12, 78, and 126 are multiples of 6. Okay, so here divide everything by 6. So you have 2y squared minus 13y plus 21 equals to 0. And for this one, okay, I will let you to continue by yourself, okay, and I will pause the video and you may have a check later. Alright, now this is the solution, the full solution for this example. Okay, so if you continue with the substitution, you found y. So usually I'll just leave y as a fraction over here because 7 divided by 2 you can get 3.5, but we'll just leave this as a fraction, 7 over 2, and y equals to 3. And for each y, when y equals to 7 over 2, substitute into the equation of the subject x, because in equation number 3, x equals to 13 minus 3y. So here, substitute the y values into 13 minus 3y. So for the first solution, this is going to be x equals to 5 over 2, and for y equals to 3, x equals to 4. Now, I would like to share a bit of the marking scheme because this is from a past year paper question. So, usually for a single simultaneous equation involving linear and non-linear equation, the mark is usually a 5 mark. So, here the methods, okay, this is when you manage to write down a substitution in full, and accuracy mark is when you have the correct quadratic. Alright, so the continuing mark is the dependent mark, the method, because here you can actually use any method that you can use to solve quadratic equation, and the final accuracy mark is when you got the correct pair. So in this case, the pair is here it should be y equals to 3, x equals to 4 as a pair. And the second pair is y equals to 7 over 2 and x equals to 5 over 2. Now, moving on to the next page. Sometimes you will face complex simultaneous equations which involves expressions with algebraic fraction. Okay. Now, at this point, if you have not reached algebraic fraction in your algebra lesson in Mathematics D or GCSE, okay, I will sort of like help you here. But let's have a look at what we have here. So here, the first equation for the simultaneous equation is x squared minus 5 equal to 0, and the second equation is xy equals to 4. So now, what you can do for this one is just proceed with making any unknown as a subject. So say I would like to make x the subject of equation number 2. So what happens here is that because initially you have xy equals to 4, and if you try to isolate x, please divide this by y. So you will have x equals to 4 over y. Okay, let's call this our third equation. So this third equation will be substituted into equation number 1. Okay, here you see why I choose x instead of y, because x is just a single term. There's no power of more than 1. But as for the y square, y, it has a square, but still it's doable. But let's have a look at what happens if you substitute equation number 3 into equation number 1. Alright, so here, what happens here is x will be replaced by 4 over y. I can please give brackets, which indicates this is a multiplication of x y square, which is changed into 4 over y times y square minus 5 equals to 0. So here, y square in this part, this is y square over 1. So 4 over y times y square means y square is divided by y. So here y square over y is y. So you will have 4y minus 5 equals to 0. So 4y is equals to 5, and therefore y equals to 5 over 4. Right? So there's only a single variable for the solution, but let's have a look. If you try to substitute y equals to 5 over 4 into which equation has x as a subject, equation number 3. So here substitute y equals to 5 over 4 into equation number 3, which is x equals to 4 over y. Is it? Yeah, 4 over y. So here the y is changed, okay, replace into 5 over 4. So here, okay, just show it like this. Okay, don't get weirded out by this. This just means that 4 is divided by 5 over 4. So if you still remember your basic arithmetic when you have to divide fractions, so you should notice that this part is going to be changed into 4 times you reciprocal 4 over 5, 5 over 4 into 4 over 5. So therefore 4 times 4 over 5 is 16 over 5. Right? So that's the working for this. But then you also have alternative working, and I will show you how to do that, because you might need this method in the future. Okay, this is like another approach to say if you encounter this kind of equation where you almost have similar form to it, but you have to make certain changes. So here in equation number 1, okay, you may also move the negative 5 to the right hand side. So equation number 1 will look like this: xy square equals to 5. So let's set that up as your first equation, and then the second equation is xy equals to 4. So this looks quite similar, and for the following methods, okay, for the following method, this is quite new and it's rarely used, but it might get useful. Okay, it might get useful in the future topics. So here, what you can actually do and check is xy on the left hand side of equation number 1 and xy in the second equation. So in the second equation on the left hand side, so here what you can actually do is try to do this: equation number 1 divide by equation number 2. So here I will just make this into a fraction form: equation number 1 divided by equation number 2. So whatever is on the left hand side, okay, xy is divided by another left hand side in the second equation. So here xy squared divided by xy equals to, on the right hand side you also do the same thing. Okay, 5 divided by 4. So if you simplify this, x divided by x is 1 and y squared divided by y is y. So therefore you are certain to have 5 over 4 straight away for your solution of y. But then you still have to find the second solution, and which is x value. So it's just a simple substitution of y equals to 5 over 4 into any one of the equations. So here I will choose equation number 2. So here y equals to 5 over 4 into 2, xy equals to 4. So x times y means x times 5 over 4 equals to 4. So here you can actually multiply the whole equation, but then you have to multiply with the reciprocal of 4 over 5. Okay, if you must know the word reciprocal, okay, is any number that you flip. For example, a fraction of 5 over 4, the reciprocal is 4 over 5. So which means on the left hand side is x, and then on the right hand side is 4 times 4 over 5 is 16 over 5. So this is one of the method that is also possible. Okay, you can copy this down and take note. You might need this in the future. Alright, let's move on to the final example. Okay, so this final example is also one of the most common type of equation, simultaneous equation that you will solve. But here, this is quite complicated as you have a lot of fraction. Okay, a fraction in the first equation. And then as for the second equation, it's just a normal linear equation. Now here, one tips that you can use if you see a fraction, okay, like this one. So what then you do is you can modify the first equation by manipulating it until you obtain this form. Okay, is this possible? Yes. So I will show on how to get it. Okay, so in equation number 1, okay, convert the left hand side. Okay, left hand side, which is the highlighted one, into a single fraction. Alright, so how you can do that is, okay, let me show you. Okay, this concept also appears in your Mathematics B or IGCSE Maths. So I will just write down the equation, the whole expression first. Okay, there's a reason why I gave gaps for here. Now, if you try to convert a single fraction, okay, let's have a look at a simple maths first. So what happens, okay, for example here for numbers, in order to make this into a single fraction, you must at least have common denominator, right? Okay, common denominator means the denominators are the same value. So here, the common denominator for this is 6. But here, for algebraic expression, if you have unknown as your denominator, so you are going to apply the same concept of multiplying the expression so that they will have the common denominator. So for this case, okay, you will learn it in the future. So y and x has a common denominator. So common denominator, okay, for you to take note, common denominator is going to be xy. So which means x times y or y times x. So here, the first fraction, to make it xy, you have to multiply this with x. So this is the first fraction, and as for the second fraction, you have to multiply this with y. So here you will have xx, which is x squared, plus 3yy is 3y squared. Everything is over a common denominator of xy. Okay, the whole fraction is equals to 4. And here, if you notice on the left hand side, this is a single fraction, so you can cross multiply the denominator to the right hand side, and you will get x squared plus 3y squared equals to 4xy. So that's how you obtain x squared plus 3y equals to 4xy in this part. So here, let's call it equation number 1. Okay, doesn't matter. Doesn't matter how you number it, as long as you remember where to substitute. And then, since you have two equations. The first equation is already in a good form, and the second equation is linear with a subject of y. So it's obvious that we have to substitute equation number 2 into equation number 1. So substitute equation number 2 into equation number 1. Now here the subject is y, so which means in equation number 1, if you see any y's, you have to substitute or you have to replace them all. Do not miss a single unknown to be replaced. Alright, that's a reminder for you. So here what happens next is equation number 1, the y will be changed into 2x minus 1. Right? So 2x minus 1. Since this is a square, so I will just straight away turn this into a double bracket of 2x minus 1 equals to, at the right hand side, 4x times y is 4x bracket 2x minus 1. This is a simple expansion, but be careful with the left hand side of the equation, especially with this one. So this one, my advice is usually make sure that you expand the double brackets first before you multiply it with 3. So this one, as for reminder, the first term in the first bracket must be multiplied first into the expression in the second bracket, and then afterwards the second term in the first bracket, -1, is going to be multiplied with the second bracket's expression. So let's have a look at what we will get. So x squared plus 3. Now this one, just write down as per usual. 2x times 2x is 4x squared, and then 2x times -1 is minus 2x. And the next term are -1 times 2x is minus 2x, and -1 times -1 is a plus 1. Equals to the right hand side, so this one is 4x times 2x is 8x squared, 4x times -1 is minus 4x. Now this one, okay, let's have a look. I will not really expand this one first. Let's simplify minus 2x, which will give you minus 4x plus 1 equals to 8x squared minus 4x. As we go further, let's expand the 3 to all of the terms. So x squared plus 12, x squared minus 12x plus 3 equals to 8x squared minus 4x. And now your objective is to make sure that you have a correct quadratic equation. So here I will move the 8x squared minus 4x to the right hand side, and it is going to be equal to 0. So for the rest of the terms, okay, I will just join them together, and let's see. For x squared, you have another like terms, 12x squared, and the 8x squared from the right hand side is going to be minus 8x squared. And for the like terms of x, it's going to be minus 12x from the left hand side, and incoming negative 4x becomes plus 4x. And the constant term is a plus 3 equals to 0. So this one, if you simplify this carefully, 13x squared minus 8x squared. Okay, 1x squared plus 12x squared is 13. 13 minus 8 will give you 5x squared. And then a negative 12x plus 4x will give you negative 8x, and the constant term is a plus 3 equals to 0. So here this is a quadratic equation, and now I will pause the video and you try it yourself to get the solution for both x and y. Alright, now if you proceed with the working and the solution, and here I just want to inform that I skipped the cross method. I also did the same around this part in example number 3. Okay, I skipped the cross method, but if you do it correctly, you should have the correct solution. Now briefly explain for the final example. For the values of x that you will get, you should have 3/5 and also 1 for the x. And then as for the y for each solution, for x equals to 3/5, you must get y equals to 1/5, and for the second solution, for x equals to 1, y equals to 1. So that's how you obtain all the solution. Alright, so with that, just to recap back, okay, for simultaneous equation with linear and non-linear equation, okay, one method is very useful, which is the substitution equation. But also a few things that you might learn recently is this, which is solving quadratic equation by factorization, okay, which requires you to factorize and then you get two solutions. And for these two solutions of x, you also have two solutions for y. And what else that we can get here? Right, generally the marks for simultaneous equation is 5 marks, and also there are certain workings that require you to be also skillful with algebraic fraction. So with that, that's the end of this video. Thank you very much and see you in the next video. Goodbye.